platform which can scale out to unlimited needs in a distributed fashion. Okay, so as I mentioned, Hadoop primarily has two core components. One is the HDFS file system, which is a distributed file system, highly fault tolerant, capable of storing big volumes of data and providing high throughput to process and manage all the data in the distributed fashion. And the second primary component is the MapReduce aspect of it. Since we have to manage big data, we cannot handle the big data in one network storage or in one SAN storage kind of storage solution. So we need a commodity distributed solution where it acts as a file system. So HDFS plays the exact role of providing it a distributed file system on a commodity infrastructure. So MapReduce is the second part of the Hadoop where it helps to build distributed processing or distributed analytics on top of the stored information in Hadoop. So what it does is primarily it is a programming model for large-scale data processing, so kind of MPP or kind of MPC kind of a approach. So also Hadoop contains common supported frameworks or common frameworks or ecosystem projects like Pig, Hive, Scoop, Flume. Using all these supported cross-functional frameworks, you could go and leverage and build a full-blown robust enterprise data warehouse solution. Okay, so little bit more insights into the MapReduce. So MapReduce is an expectation maximization technique where the job is split into smaller tasks so that it can be executed in a distributed fashion. When you split the bigger job into smaller tasks, it's more of a divide and conquer approach. So you can achieve X amount of work when it is split into smaller pieces. So you can divide that into X by say N number of pieces and achieve that in a smaller time with all the fault tolerance, the coordination, the cluster management taken care by the Hadoop framework. You need to only focus on the business logic or on the actual business aspects of the MapReduce. Okay, so quickly we'll do a comparison of Hadoop versus RDBMS. So RDBMS, you have to have a fixed schema. When it comes to Hadoop, you don't need to have a fixed schema, it is all flexible. And in Hadoop, basically, you may have to do some sort of always a write operation to start with. There are few enhancements which started happening the append as well. In case of RDBMS, you can do a lot of update, read, delete operations. So some of those operations are not available in your traditional in your Hadoop platform. And also your traditional RDBMS reads are faster comparatively when it comes to Hadoop. The loads or the writes are faster. So Hadoop is fine-tuned for better performing writes, and RDBMS are fine-tuned to better performing reads. And RDBMS are based on some standards like ANSI SQL and some fixed way of defining the schema and interacting with that schema. So whereas Hadoop does not have any fixed or standards where you have to interact in this way, it is more informal, very flexible kind of interaction with the Hadoop storage and the MapReduce. So some of the differences also you would see when to use RDBMS based solution or enterprise data warehousing versus Hadoop is, say if you need to have very high performing low latency queries, so you cannot use Hadoop straightforward. And when it comes to large volumes of data and you're okay to sacrifice performance, you can go for Hadoop. And when it comes to ACID kind of features or consistency with moderate amount of data, you can choose RDBMS, not Hadoop. So when it comes to functional features like counting, sorting, cursors, triggers, joins, complex querying needs, ad hoc queries, with moderate or reasonable data volume, RDBMS fits the bill with low latencies. Okay, so Hadoop really fits the bill when you have huge volumes of data, structured, semi-structured or unstructured. You need flexibility with the schema, and you need to store this data and process this data in a distributed fashion. So that's where you have to go for Hadoop. Okay,